That's it. Software engineering is dead. As of tomorrow, I'm going to be looking for a new job in a field that is AI proof. Or at least that's what every AI maximalists want me to make a video and say. However, I don't believe that this is actually the case, and this is the list of reasons why. Unlike what many project managers want you to think, software engineering is way more than just taking an issue and spitting out code and closing a ticket. This is probably the happy path where everything is going right and we have been able to distill the essence of what we need to build and write it in a few phrases of text. Everyone who worked in software engineering for any period of time knows that this is the exception and not the norm. Software requires us to have many conversations with many stakeholders. It requires us to compromise on the design elements. Sometimes we even go on excursions to discover how something can be done before we evaluate what do we actually want to deliver based on our findings there. And even then, we have to go through many stages of design sessions, code reviews, pair programming, you name it, before we are actually able to ship a piece of code to production. And after that, sometimes we have to debate and think about what we want to refactor, what we want to remove from the code base, and what we want to optimize, and what are all of the costs of doing such things. Throughout all of these steps, we are required to have a mental model of the code base that we are working with and that we are able to reason about. Now, beyond the code base, we have to manage also what we build operationally because we are deploying this to different infrastructures. We need to manage what could happen in production. We need to manage downtimes. We need to manage attacks. We need to manage security problems. We need to manage all sorts of issues that come from the need to maintain this piece of code. And this is what software engineering is about. Saying that software engineering is picking a ticket and delivering it is just like looking at a branch of a tree and saying this is the tree just because you think or you want it to be like that, but this is not actually the case. Reason number 2, LLMs cannot reason, they cannot think, they cannot solve problems. They are impressive simply because of the space that they can look up information within and the space of the training data. This magnitude affords them the ability to branch out in so many different paths to come up with answers that seem human-like to us. But without their impressive and gigantic training data, they're not really able to do much on their own. And this is very different from what human beings are capable of doing. If you get a human being and put them in an isolated environment, they will be able to build a model of the world. They will understand so many things about the world around them without being fed any training information. Even if they're not going to have a lot of information about the external world, they are at least able to build, a model of the space surrounding them and how they can interact with this environment that they are operating within. And this is a major distinction between what we can do and what LLMs can do at this point in time. Number 3, we don't just look up information online as software engineers. Yes, we Google a lot. Yes, we do a lot of research. However, the main point here is that we are able to assess whether the information we found is actually reasonable for the problem that we are trying to solve, and we're able to assess the cost of the implementation. We're also able to assess all of the derivative problems that might come from introducing that piece of information that we found online into our code. Number 4, verifying correctness of solutions is a very difficult problem. Ask anybody who has worked on researching formal algorithmic proofing methods, and they will tell you that this is an extremely difficult problem to solve, and it is an open research topic at this point in time still. Which begs the question, if we trust agents built on top of LLMs to actually go and look up information and solve problems for ourselves, how do we verify that they have actually correctly resolved the problem that we have handed them? You might say, if they build a feature, we can test it. Great. How far can you test? And then some people might say, well, we could have another agent perform the tests according to certain criteria. Great. Who defines this criteria? Are you able to define the criteria before you even actually embark on the design journey? But the problem with software engineering is that a lot of the constraints of the problems we're dealing with and a lot of the constraints of the solutions are discovered along the way. That is why software engineering is an iterative process, because we learn new things, we feed them back into the problem, and we keep on iterating until we get to the desired outcome. As much as people would like to think that things are black and white, you feed a certain input, you feed a certain problem, and you get an output, and then you test the output based on the input that you have provided, things are much more complicated than that. Number 5, agents are definitely handy. Yes, I have seen Devin. Yes, I have seen all of the different derivatives and variations of that. Who hasn't? But they still operate within the space of being co-pilots, and they are not in the driving seat yet. Number 6, a lot of people are claiming that progress in this field is going to be exponential. And this couldn't be any further from the truth, because the leap from LLM to AGI might be greater in size and in duration than the leap from nothing to LLMs. It took us many decades to get to the point where we are today. LLMs are nothing new. They have been there for at least a decade as a research topic, and many elements have to come together before we have such a similar breakthrough. LLMs are not necessarily a scientific breakthrough in and all by themselves. They have stretched the theory of scale to its limits. Ilya was actually a visionary in this field. However, we don't know how far this can be taken, and we don't know what are the limits of pushing this boundary to its edge. And I'm getting the hunch that we are probably getting to the limits of what scale can offer, and we really need to reevaluate the architecture of these models for us to make further progress. I'm pretty much in the Jan LeCun camp when it comes to this topic. I believe that a re-architecture and the reintegration of multiple architectures is necessary for us to get to the level of artificial general intelligence. These areas have been researched for the past few decades, but we are not there yet. Number 7, when the jobs of software engineers are taken by AI, the entirety of humankind will have to worry about their jobs. Because at that point in time, we have created machines that are actually intelligent. They are able to solve problems. They are able to reason. They understand the world. They have a model of the world. They are able to find new solutions and inventive solutions within the entire space of information and input that they have. And at that point in time, they are pretty much boundless in what they can do and what they can achieve. Machines are going to be able to do better diagnostics than doctors. Any job that comes to mind, copywriters, videographers, cinematographers, anything that requires any form of creative output will and can be done by a machine at that point in time. And you might say, well, maybe the safety is actually in physical jobs that require, a physical presence in the world. And at that point in time, I really doubt that the AGI will not be able to come up with algorithms that are going to be operated on machines that have access to the physical space. So nobody's safe. At that point in time, we have to revisit what society is all about. We have to revisit our socioeconomic models. We have to revisit the concept of jobs even, because nobody is going to have a job. And then there's going to be a huge competition over resources. Operating AGI is most likely going to be a resource-intensive operation, and we have to really specify where and for what purposes do we use this, if we even exist as a humanity on this planet at that point in time, and we have not either obliterated ourselves out of existence or AGI has taken over because it optimized for its own self-preservation needs and determined that human beings are not really serving that particular purpose. And this is why I say it's great that we are having these debates, and we should continue having these conversations way more often. However, it's way too early to talk about, AGI or AI or anything like that replacing complicated jobs like, for example, software engineering and any other job along the same lines. And until then, the best way you can mitigate against your job being eliminated is to build depth. It is to actually build a lot of knowledge, specialization, and concrete depth in various topics. And this is going to be a big differentiator for us over the machine. I obviously have so much more to say about this topic, but let's just stick to this right now. Nobody's job is going away for the foreseeable future, but I think the short-term and medium-term future is going to be very, very exciting, because we're going to have amazing tools that are going to allow us to do our job way more efficiently and way more effectively. And we're gonna start dealing with problems at a higher abstraction level, just as much as calculators, helped us do math, and just as much as computers in general have helped us do things in a much more effective and optimized manner. I'll catch you next time.